Let f of x be 4x e to 2x. Find f dash x. No hassle. I'm going to use the product rule of differentiation. U can be u, u can be v. Okay? U is 4x, du dx is 4, v is e to the 2x, v dx is 2 e to the 2x. Is that okay? Now, f dash x is the following. U times the v dx, so it's going to be 4x times 2e 2x, yeah, plus v times the u dx, e to 2x times what? 4. And what does that give me? 4 e to 2x, and the other one is 8x e to the 2x. Okay. What's a fancy way of saying f dash x? Would you all agree that f dash x is actually the same thing as? Would you all agree it's the same as the y dx? The first derivative, and if I could rewrite this, I could rewrite this as y. Would that make sense to you guys? Now, there's something I'm going to show you that you might not be familiar with. Is everybody happy with the differentiation part? Happy enough? Now, imagine I asked you to integrate something really simple like this. Okay? I could write this in a different manner. Let me show you how I'm going to write it in a different manner. I could write that as integrate x squared plus integrate, let's say I had to write the dx every time. Do you see what I'm doing? I'm treating all parts as separate, but I still get the same answer, don't I? It will still be x3 over 3 plus, what's that, x squared, so 5 over 2x squared. And then there'll still be a 9, won't still be 9x. And you see, and then c at the end. Do you see the way I'm allowed to use the integral on each part individually? You see that? That's your first time saying that, isn't it? That I'm writing it separately as opposed to doing it all in one go. Now, what you might be asking is, why am I doing that? Well, here's the reason. If I go back here, I look at my answer, okay? And what it wants me to isolate is, it wants me to isolate this part here. And it wants me to integrate it. So what I'm going to do first and foremost is, I'm going to get the y here. I'm going to ping up the dx. So it's going to be 8x e to the 2x dx. And then the other one is going to be 4 e to 2x dx. And I'm going to treat them as separate integrals. Is that okay? I'm going to treat them separately. And if I integrate the right, I must integrate the left. We on board so far? I'm going to pause here. The reason why I'm applying it separately is the whole point of the question is to isolate this part on its own. So did everybody see that part? It wants that part on its own. So how do I get that part on its own? What do I need to move over the other side? It wants the green part on its own. So what do I need to do? What do I do with this part over here? Move over to your side. Would everybody agree that's 1 to y? Would everybody agree that's it is, yeah. Minus 4 e to 2x dx, and that equals. Now, I don't know how to integrate the green part. It's like a product rule, isn't it? But there is no product rule for integration. So I leave that part alone and I do the other side. What happens when I integrate 1 to y? What do I get? Y. What happens when I integrate 4e to the 2x? 4e to the 2x all over, which is 2e to the 2x, yeah? And then I should probably put a c at the end, shouldn't I? Because both of them combined will have some sort of number. Okay? Oh, there's no 2 on the bottom. It's gone, yeah. Okay, now what? ax e to the dx, yeah? Now, see the y, what can I replace that with? There you go. And that's your answer. The answer is 4x e to the 2x minus 2 e to the 2x plus c is the integral of that. Come in after that. The differentiation part is made up of two parts. I'm going to treat 2x e to the 3x as a product rule. So I'm going to say that u is 2x, du dx is 2. I'm going to say that v is e to the 3x, therefore dv dx is 3 e to the 3x. Now I'm going to differentiate just this part here using the product rule. U times dv dx plus v times dv dx. Now, I think the way this works is this is going to be 6x e to the 3x. Now, what happened? Sorry guys, du dx is 2. Well spotted. Okay, and we get 2 e to the 3x. Is that okay? Now, what did I forget about? What does cos turn into when you differentiate it? We all agreed on minus sign? And are we all happy that that's dy dx, are we? Now, what I'm going to do is I'm going to cross multiply up the dx now. So it's going to be dy equals 6x e to the 3x dx. It's going to be 2 e to the 3x dx. And then it's going to be minus sine x dx. Now what are we going to do to both sides? Can anybody tell me? See, I'm after the integration sign. I'm going to stop here and let you finish it yourselves. That's where you're at now. Here we go. I integrate 1 to y. What do I get? Just get y, don't I? This is the goal of the question, isn't it? Yes, it is. That's the goal of the question, isn't it? So, because that's the goal of the question, I'll probably just I can't clone her automatically. Yeah. All right, let's write that back in again. What's it called? 6x e to 3x dx. Okay. Integrate this one. E to 3x 2/3. Is that okay? And then what happens when you integrate sine x? Anybody know what sine x turns into when you integrate it? Is it minus cos or cos? What? So double negative then, is it? Double negative to make cos. Now, there's some constant here, isn't there? Well, I'm not going to worry about that constant until I move everything over the other side. Is that right? So it's going to be y minus 2 over 3 e to the 3x minus cos x. Does everybody see that I'm moving it over? Now I'm going to introduce the plus c on that side. Okay. What do I need to change y into? Anybody? Y is all of this. 2x e to 3x plus cos x. Two x e to 3x minus plus cos x. So what happens to the cos x's? They cancel, don't they? So what's left over then? 2x e to 3x minus 2/3 e to 3x plus c. All of this crap here. That's our answer. All right.